Okay, let's solve some more of these equations and just get into the habit of solving these things by using these very simple techniques in order to untangle these really complicated looking equations. Now here's one. This is one of these sheeps in wolf clothing question. E raised to the natural log of x minus 1 equals 4. Now there's two ways of answering this, two ways of solving for x. Step one is to be lazy and think and say, wait a minute, what does this equal? This right there, that is the exponent that I have to raise e to in order to make it x minus 1, right? That is the exponent. That's the power I have to raise e to in order to have it be x minus 1. Look what I'm doing. I'm taking e to that power. So what does it equal? It equals x minus 1. Because I'm raising e to the very power I have to raise it to in order to get x minus 1. So I can immediately just say, right from here, e raised to the natural log of blop, those two things cancel each other out, and I'm left with just x minus 1. Therefore, x equals 3. So easy, so easy. You can check your answer by putting in a 3 here. See, 3 minus 1 is 2. And so what I see here is e. No, I made a mistake. Look what I'm doing here. What a nut. You know, I get so excited because I got to an easy thing. Look what I did. Do you see it? I brought this over and it became a 3. Right. If you bring this over, I've got to add. And let me give a little lesson in addition. And the lesson is the following. If you have 4 plus 1, that actually equals 5. Whoa. Now, here's a place where I made a mistake, but I'm not going to worry about it at all, because whenever I see a log, I always check my answer. And I found that mistake when I was about to check, because it wasn't working out. I was getting a little wet under the collar. Now, let's check the answer now. If I put a 5 in there, 5 minus 1 is 4, and e to the natural log of 4 is 4. That checks. So, in fact, an easy way to do this problem is just to realize that e raised to the natural log of blop is just blop. In fact, in general, if you have a base b raised to the log base b of something, that always equals the something. They undo each other. They're actually inverse functions, so they cancel each other out. I'm left with a. Now, suppose we didn't see that. Okay. Let me just show you that, in fact, this is really something we could answer even if we weren't sort of really slick like that. I could think, well, wait a minute. I've got the x's in the exponent, so I'm going to take the natural log of both sides. If I take the natural log of both sides, I'd see natural log of e to the natural log of x minus 1, and that equals the natural log of 4. Now I use the property of exponents and logs that says if you've got an exponent there, it becomes a coefficient. That's the whole reason why you take the natural log of both sides here. Natural log of x minus 1 times the natural log of e equals the natural log of 4. But what's the natural log of e? Remember that the natural log is log base e. So this is log base e of e. So that's what I have to raise e to in order to get e. Well, e to what power gives me e? 1. So in fact, this is just 1. So I can just drop that out, and I see natural log x minus 1 equals natural log of 4. And now what you could do? Well, since I have the natural log of something equals the natural log of something else, those somethings must be equal. So therefore, I see x minus 1 equals 4. And then if you do it incorrectly, you'd say x equals 3. If you do it correctly, you'd say x equals 5. There's the answer. Got it before in one step. Here I did it in 1, 2, 3, 4 steps. Either way, it's perfectly correct. Let's try another funky one. Here's a funky one. A little funky one. A little funky music. Some dancing music.
Oh, yeah!
Because this is a log of x equals 1. What do? Just follow the procedure that we already talked about and worked on together. When you see logs, untangle them. Now this is going to be a untangle. Log, remember invisible base 10 there. So what does this mean? It means that log is the exponent. So 10 to the first power equals that. So what this says is 10 to the first power equals that, log x. Now what do you undo? Untangle again. Just keep untangling. This is invisible 10 here, and so what do I see? Log is the exponent. 10's the exponent I have to raise 10 to in order to get x. So x equals 10 to the 10. That's a big number. That's a 1 with 10 zeros. That's a lot of money if this were cash. And again, you can check your answer, and you should check your answer because you got logs there, by plugging this in. So what's log of 10 to the 10? Let's think about that. What do I do? Well, first of all, this little 10 exponent can be pulled out in front of this. So that equals log of, and then I pull that 10 out, and I see 10 log of 10. Well, what's log of 10? Well, remember, log of 10 is log base 10 of 10. That's the exponent I have to raise 10 to in order to get 10. So 10 to what power equals 10? Well, 1. So this is actually just 1. So I have natural log of 10 times 1. And what's the natural log of 10? Well, that's still 1. And so look, we get the 1. So this checks. Cha-ching! So the answer is the big answer of 10 to the 10 power. Pretty big, pretty big. Okay, let's see. The last one I want to take a look at is the natural log of e to the 3x equals 6. Well, I don't have to even worry about taking logs here because I have log of something here. So this immediately comes out in front without any labor at all. And I see 3x natural log of e equals 6. What's natural log of e? That's log base e of e, which is 1. It's 1. Natural log of e is 1. So I just see 3x equals 6, so x equals 2. You can check that answer by putting this back in, and I see natural log of e to the 6. Does that equal 6? Well, I bring this out in front, and I see 6 natural log of e, but natural log of e is 1, so this is a 6. So in fact, it does check. The reason why I'm so happy, and the reason why that's the last question, is because watch what happens if I take away this piece of paper. That's right, folks. I've ran out of paper, and thus ran out of material. I'll see you up in the next lecture. We'll reload.